Okay, I think it's recording. I'll see how it goes. All right, so today's lesson, this is the last thing you'll need for your quiz next Wednesday, which is you need to know how to find the inverse of a function. So for starters, let me tell you what is an inverse. The inverse of a function is the relation formed when the independent variable, which is your x variable, is exchanged with the dependent variable, which is the y variable. The inverse of a function may not always be a function, and that's okay. So let's actually try and do an example together. The first example is actually already done for you. We just need to analyze it. So here it is, example 1. You need to be able to graph the inverse of f of x, which is equal to the absolute value of x plus 3 plus 2. So you got to know how to graph the inverse of that for your quiz next week. So here's the steps. Step 1. First graph f of x. It's already been graphed for you. This absolute value function has a vertex of negative 3, 2. So that's been graphed. It's got a slope of 1. So up 1 to the right 1, up 1 to the right 1. Okay, so that's been graphed already. So step 1 done. Graph f of x. Step 2. Make a table of values for f of x. And make sure you always include your vertex in your table of values. Negative 3, 2, that's the vertex. Make sure you always include the vertex. And then just go ahead and put like a couple of points to the right of the vertex and a couple of points to the left of the vertex. So step 2 is done. Make a table of values, including the vertex. Step 3, here's how you actually do the inverse. So this is the inverse right here. To do the inverse, you do what the definition says. Switch or exchange the x and the y variables, or the x and the y values. So in other words, all the x's, negative 1, negative 2, negative 3, negative 4, negative 5, that became the y values. And then all the y values, 4, 3, 2, 3, 4, became the x values. And that's how you find an inverse. So that's your very first inverse right there. Now you can also graph it. So let's go ahead and graph it. So to graph the inverse, you're just going to literally graph these points here, this table. So go ahead and graph 4, negative 1. It's already been graphed. 3, negative 2. It's already been graphed. The vertex is now 2, negative 3. It's done. 3, negative 4, and 4, negative 5. So that's how you do an inverse. So on your quiz next week, that's what you'll have to do. You'll have to graph the inverse. So those are the steps. Finally, the last thing you need to know for the inverse is how to write an equation to describe this inverse. This inverse is a sideways v, and it is not a function. Because if you were to do that vertical line test, this is not a function, and that's okay. So the last step, go ahead and describe the inverse relation, so this sideways v, with a pair of equations. A pair means two. Like you've got to have two equations to represent this sideways v. And here's what the two equations are. It's already been done for you. Y equals x minus 5 and y equals negative x minus 1. But let me show you where that comes from so that you know how to do it. So this sideways v has two parts. Okay, let's focus on the top part first. The top part of the v is the line with the positive slope because it's going up 1 to the right 1, up 1 to the right 1. So that has a positive slope. So you would put like y equals 1x. And now if you were to continue that line with the slope the other way, you should be able to find the y-intercept. So if you were to continue that line, you should be able to find the y-intercept, and it looks like it's minus 5. And that's how I got this y equals x minus 5. So that would be the one of the equations. So on the quiz next week, it's going to ask you for a pair of equations, which means give me two. That will be the first one, y equals x minus 5. Okay, now redo and find the other equation. So the other equation involves this bottom part. So again, the bottom part has a negative slope, like y equals negative x, because it's going down 1 to the right 1, down 1 to the right 1. And again, try to extend it the other way. Up 1, left 1, up 1, left 1. And you should be able to see the y-intercept. It looks like negative 1. And that's how I got the other answer. Y equals negative x minus 1. So you do need to know how to do that for the quiz. And those will be your two answers. Y equals x minus 5. Y equals negative x minus 1. And now finally, the last thing, which is the hardest to understand, is this domain restriction thing. So if you don't put a domain restriction, like if you just say y equals x minus 5, y equals negative x minus 1, your graph is kind of what I drew right now. It's like an X, like the whole positive line, y equals x minus 5, with all real numbers, and then the y equals negative x minus 1 is all real numbers. So that, if you just leave the equations like that, they make an X. But remember that your inverse wasn't this whole X. The inverse was just the sideways V, which started at x equals 2. It started at x equals 2, and then it went to the right. And that's where these restrictions come from. So x is greater than or equal to 2. Now, with that, I'm going to pause the video so that you can try example 2. I'll walk around with the answers to see if you have any questions. And I need you to do example 2 by yourself the same way. So, example 2. Given this function f of x to absolute value x minus 4 minus 2, find the inverse. I'll get you started with step 1, just to make sure you do it right. Step 1, graph f of x. F of x has a vertex at 4, comma, negative 2. So 4, negative 2. And then it has a slope of like 2. So up 2 to the right one. Up 2 to the right one. And then the other side is symmetrical. Up 2 to the left one. Okay. Now, you do the next. So let me pause the video. And go ahead and graph f of x. Make a table of values. Flip the x and the y values. And find the inverse. Okay. So I'll post the video. And I'll post it on YouTube so that you can play like a faster speed, like 1.5 speed. Anyway, so example 3, let's do it again. Graph the inverse. To graph the inverse, you're going to have to first graph f of x. So f of x is 4, negative 1. And this time there's a negative on the outside of the function, so it's going down. Like that. And so it would look like that. So that's just f of x. Now you actually have to graph the inverse like you did on the example 2. So to actually graph the inverse, you would make yourself a little table of values, including the vertex. So 4, negative 1, 5, negative 2, 3, negative 2. So that's f of x. So now go ahead and actually graph the inverse by flipping the x and the y values. So now your inverse should be negative 2, comma 3. Negative 2, comma 3. So this is the official final answer. Negative 1, comma 4. And negative 2, comma 5. This time, the v is actually going to the left, like that. All right, so there's the inverse. Just that one. And letter B says, what is the pair of equations to describe the inverse? So it looks like one of the equations is negative x plus 3, and the other one is positive x plus 5, because again, you would have to extend it so that you can find the x and y intercepts. And last but not least, you're going to have to do the domain restriction on the inverse. So this inverse now is starting at negative 1 and is going less than that. So your restriction here is x is less than or equal to negative 1. And the domain restriction will always be the same for both of your equations. Always. So there is my inverse. Those are the pair of equations that describe the inverse, and that's the domain restriction. So now, that's how you find an inverse graphically. But you also need to be able to find the inverse algebraically. So like without graphing, you should be able to get to the final answer the same way. So like without this graph, I need you to do letter C. Go ahead and try to find the inverse algebraically. And it's just going to be quicker than graphing. If you have time, you could graph to find the inverse, but you should be able to do it algebraically as well. So let's pretend we don't know the answer, and let's do it. Letter C. Find the inverse of f of x algebraically. To find the inverse algebraically, First, switch the x and the y variables in the equation f of x equals negative absolute value of x minus 4 minus 1. So in other words, instead of putting y equals, go ahead and put x equals negative absolute value of y minus 4 minus 1. So start with that. So again, now I'm teaching you how to find the inverse algebraically. So you should be able to get to the, we already know the answer. The answer is y equals x plus 5, y equals negative x plus 3. We already know the answer. But here's how you get that without having to graph it. Switch the x and the y variable. Now solve for y. So this is called an absolute value equation. To solve for y, you have to isolate the absolute value of y minus 4. So plus 1, x plus 1 equals negative absolute value y minus 4. Get rid of the negative, so negative x minus 1 equals absolute value of y minus 4. And then if you remember anything from last unit, the way you solve an absolute value equation is you break it into two cases. The first case should be just what you see is what you write. The second case should be like the opposite. So first let me start with the first case. Negative x minus 1 equals y minus 4. And then the second case, I like to switch it to positive x plus 1 equals y minus 4. And once you solve for y, you'll get the two answers that we already know. You'll get y equals x plus 5, and you'll get y equals negative x plus 3. So add 4, y equals, this is going to be negative x plus 3, and this one's going to be y equals x plus 5. The pen is about to give out. All right. So that's how you're going to find it algebraically. So on the quiz, it will ask you to find some of the inverses algebraically. You're not going to have time to graph it. It's going to be just faster to do it this way. Algebraically, switch the x and the y and solve for y. And now the hardest part for students to understand is like the domain restriction. Obviously, I already know the answer. The domain restriction was x is less than or equal to negative 1, because you can see it on the graph. Like the domain here of this sideways v starts at negative 1, and it goes to the left. But like, how do you tell the domain restriction without the actual inverse? Here's how you do it. It has to do with this question down here, so let me answer it. How does the graph of f of x affect the domain restriction of the inverse? Okay, you're going to have to know this by heart, but let me write it down. The domain restriction of the inverse. So let me write it down, and I'll say it like 10 times. Domain restriction of inverse. So domain restriction of inverse equals range of f of x. You've got to know that concept because there's multiple choice questions on it, on the quiz. So one more time. The domain restriction of the inverse, so this answer here, which I'm going to put right here, the domain restriction of the inverse is always equal to the range of f of x. Because remember that in inverses you switch the x and the y, so the domain is a range and the range is a domain. They're flipped around. So one more time, here's what it means. The domain restriction of the inverse is equal to the range of f of x. So remember in example 3 when I graphed f of x? Let me go back to it. Here's my picture of f of x. Find me the range of f of x right now. So I want you to find the range of f of x. It should be a y value, like y is less than or equal to. So find me the range of f of x. If you do it correctly, the y values of f of x should be y is less than or equal to negative 1. Because it goes from negative infinity to negative 1. So there it is. So this is the range of f of x, and that's going to be the domain restriction. Instead of putting y is less than or equal to negative 1, notice how it became x is less than or equal to negative 1. Because when you switch from f of x to the inverse, you got to switch the x and the y. So that's what this question means. The domain restriction of the inverse, so x is less than or equal to negative 1, is the same thing as the range of f of x. Y is less than or equal to negative 1. Just switch the letters. We'll do it again. We'll do that again and practice it one more time. But now, make sure you understand that and practice that for the quiz Wednesday. And now, that was kind of hard, but then here's about to get more difficult. Is the inverse of the absolute value function a function? Already answered that for you. No, it's not, because remember that the sideways v fails the vertical line test. So now, if you're not totally lost now, here comes the hardest part. We are now going to go ahead and try and graph the inverse of the absolute value function, but we want the inverse to be a function. So here's how we're going to do it. Example 4. Given this f of x function, how can we possibly restrict the domain of f of x so that the inverse is a function? The way you're going to do it is by following these steps. Step 1. To restrict the domain of f of x, we will only be graphing half of the absolute value function. Either the right half or the left half of the vertex. Okay, first, let me give you like a preview of what I'm talking about. So, anytime you graph an entire absolute value function, so an entire v, if you graph the entire v, the inverse will never be a function, because if you graph this entire v, your inverse is a sideways v. So what we're going to do in example 4 is, instead of graphing this entire v, you get to pick, like you get to choose, only graph half of this v. So for example, like I always like to go to the right of the vertex, because I think it makes it easier. So I'm only going to graph half of the v, which is like this little ray. And if you do that, once you find your inverse is only going to be the like that part. So if you only graph like the ray instead of the whole v, once you find the inverse is just going to be the top part or half of that sideways v. Now that's a function. So that's what we're about to do in example 4. We're only going to graph half of the v, and therefore the inverse will be a function. So let's try it. Example 4. To restrict the domain of f of x, we will only graph half of the absolute value function, either to the right or to the left of the vertex. So first let's find the vertex. Negative 2, 5. So let's do that. Negative 2, comma 5. 1, 2, 3, 4, 5. The slope is negative 1 over 2. So done 1 over 2. Done 1 over 2. And now here's what I'm talking about. Okay, I guess I'll graph both, but then I'm going to erase one. So you get to pick. Don't graph the whole v like I just did. You need to only graph either to the right of the vertex, which is my favorite, or if you want to be different and you want to graph to the left of the vertex, you can. I'm only going to graph to the right because that's my favorite. So there we go. So now, since I chose to go to the right of the vertex, here's the restriction. X is, I need another pen. X is greater than or equal to negative 2. So I'm only graphing greater than or equal to negative 2 because I only want to graph to the right of the vertex. If you want to be different and graph to the left of the vertex only, you should be writing x is less than or equal to negative 2. But right now, we're going with my way. Greater than or equal to negative 2. Now go ahead and try letter B by yourself. Letter B. Now that you have restricted the domain for f of x, go ahead and graph your inverse function. This little f negative 1 means inverse function. So that just means that when you do the inverse now, that inverse will be a function. And if you forgot how to graph an inverse, you have to make a table of values and flip the x and the y. Or honestly, like I just flipped them in my head. So for example, negative 2 comma 5 will be 5 negative 2. 0 comma 4 will be 4 comma 0. 2 comma 3 will be 3 comma 2. So I'm just flipping them in my head, and you can do that too on your quiz. 4 comma 2 will be 2 comma 4. And then that's all I got. So it kind of looks like that. Looks like that. So what I just ended up graphing right now, that's called the inverse function, because that is a function. If you do the vertical line test, that is a function. So I need you to find the equation of that function. You can find the equation of the function by looking at the line. Go ahead and find the slope. Find the y-intercept. And don't get confused with that arrow. That line has a negative slope. the slope is negative 2, down 2 over 1, because in math we read from left to right. So find the slope, which is negative 2, and find the y-intercept, which I believe is 8. So here's my equation, negative 2x plus 8. 2x plus 8. Which we're going to do again on letter C, but this time do it algebraically. Now we're not done yet. The inverse, negative 2x plus 8, also has its own restriction. So it says it down here, make sure that you state the restriction for the inverse 2. So now remember that the inverse, the domain restriction for the inverse should be the range of f of x. Or right now you can just tell it, you can see it because you have the graph. So the domain for this graph is x is less than or equal to 5? Yeah, x is less than or equal to 5. So, and you can see it like to the left of 5. Now, if you didn't have the graph, if you're just doing it algebraically, the domain restriction of the inverse should be the range of this other function of f of x. And if you look at your range over here, the range of f of x is, what is that, y less than or equal to 5. Which is why that became x is less than or equal to 5. Now let's just do it one last time on letter C. Let's do it again. This time I need you to try to do it algebraically. So let's try that. Yeah, we got time. So example 4. You first did only graphed half of the absolute value. Then you flipped the x and the y. Then you found the slope and the y-intercept. And then you did the domain restriction. Again. Now let's do it algebraically. To find an inverse algebraically, remember that you have to switch the x and the y variables of f of x. So instead of putting f of x equals, let's put x equals negative 1/2 absolute value y plus 2 plus 5. So go solve for that. So let's solve for y here. Minus 5, so x minus 5 equals negative 1/2 y plus 2. And to get rid of that negative 1/2, I guess let's multiply by negative 2. So negative 2x plus 10 equals absolute value of y plus 2. Now again, here comes why this is the hardest question. To solve for y, remember that you're supposed to establish two cases, but you're not going to do that. If you establish two cases, you end up with two equations, which is not what we want here. So here, you only establish the first case. So let me make that note. Only establish case 1. Case 1. And case 1 is what I like to call the positive case. So only establish the negative 2x plus 10 equals y plus 2. And the reason why is because remember that we only graphed to the right of the vertex. So if you choose to graph to the right of the vertex, you're only choosing to do the first case. And this is going to give you the answer to the inverse function. Now, from the very, very beginning, for those of you that chose to do it differently, any of y'all that chose to do less than the vertex, and you chose to do less than or equal to negative 2, if that was you, then here, when you do your two cases, you should only be establishing the negative case. But to me, that's always harder, so I always just do graph to the right of the vertex and only establish the positive case, case 1. So finish this. This will be negative 2x plus 8 equals y, or I'm just going to call it f inverse of x. You can put equals y, that's fine. Or you can just call it f inverse of x. The reason we can call it f inverse is because this negative 2x plus 8, that is a function. It's a line. And then one more time what it says here, don't forget to do the restricted domain of the inverse. We already have the answers right here. X is less than or equal to 5. If you don't put a domain restriction, then you're saying that the inverse is a line, negative 2x plus 8, and it's not the entire line. It's a line, but it starts at 5 and less. So now, you still have about 10 minutes. I need you to practice. So I think that was the hardest. Yeah, see if you can do example 5. I'll walk around with the answers, and that's it. So for homework tonight, you got to practice this inverse stuff. Let me stop the video.